Let's explore this official GMAT problem. To get the most benefit from this video, pause the recording now and solve the problem for yourself. The correct answer is C. What kind of problem is this? We've got some information in the passage above, and we're trying to work out which of the answers must be true based on this information. Notice that, unlike in most critical reasoning problems, the passage above doesn't contain an argument. It contains just some facts, and these facts need to support the correct answer. This is just like premises supporting a conclusion in a strong argument. We could think of this question type as finding the conclusion. Another name for this is inference. Let's take a closer look at what an inference is, and we'll come back to this problem in a minute. If I tell you chocolate ice cream is Bob's favorite kind of ice cream, what else must be true? You're probably thinking he must like chocolate. That seems reasonable, but it's not good enough for the GMAT. It's possible, if a little weird, that he likes chocolate ice cream, but not chocolate itself. On the GMAT, inferences must be 100% certain. So you're thinking, he must like ice cream? Unfortunately, the same applies. We don't know for sure that he likes ice cream. Maybe he's not really an ice cream guy after all. That's not a good inference. But what about his past experience? For chocolate ice cream to be his favorite, he must have tried chocolate ice cream. Definitely. And also, favorite means number one, and you can't have number one without a comparison. So he must have tried at least 2 kinds of ice cream. That's a good inference. And how about vanilla ice cream? Well, if chocolate ice cream is his favorite, then vanilla can't be. Vanilla is not his favorite kind of ice cream. That's a good inference. Notice that this inference was pretty boring, but it was also safe. It's kind of mathematical, and that's a kind of inference that we're going to see very commonly on the GMAT. Okay, back to the problem. We're told that Merton County has a higher percentage of 40,000 plus households, and Summer County has a higher percentage of 60,000 plus households. It looks like Summer County is the richer county, but watch out. Answer A claims something about 80,000 plus households, but we don't have any information about them. Maybe Summer County has no households that are higher than 80,000. We don't know, and therefore A doesn't have to be true. We can eliminate it. Answer B makes a claim about Merton being the second highest percentage, but hold on, there could be other counties involved. Answer B doesn't have to be true. Answer D makes a claim about the number of households. This is like a quant trap. We've got information about percentages, but that doesn't tell us about actual numbers. Perhaps Merton County is a lot smaller than Summer County, so that a higher percentage doesn't mean a higher number. D doesn't have to be true. Answer E makes a claim about averages. There's another trap here. An average can be disturbed by a single outlier. Imagine somebody extremely wealthy moved to Merton County. They wouldn't make much of a difference to the percentages, but they could pull up the average. Answer E doesn't have to be true. The correct answer is C. Notice that I solved this problem just by eliminating wrong answers. In fact, that's often a very good strategy for inference problems. I tested the answers to see if each one had to be true, and I eliminated an answer if I could find a way for that answer to be false. Kind of like testing a case to see if it was possible for the answer to be false. Also, note that C is the boring answer choice. It doesn't make any big claim. If you're looking to guess on inference problems, guessing the boring answer choice is a good move. However, to finish, let's understand why C is a good inference. I'm going to prove that C must be true by considering the opposite of C. Imagine that there were no households in Merton County with an income between 40,000 and 60,000. That would mean that all the households that were 40,000 plus would actually be 60,000 plus, and that would create a problem. The percentage of 60,000 plus households in Merton would be higher than Summer. But we know that the percentage of 60,000 plus households is higher in Summer. We've got an impossible situation, a contradiction. This shows that our starting point, the opposite of C, is not possible, so that C must be true. Phew. Notice that this logic was much more complicated than just eliminating answer choices. Check out the link below for a follow-up task.